On your guys' announcements, and if you can't access that right now, then just go onto Google, type in UCF Study Union 2018, click on the chemistry tab, and just scroll down to my name because I uploaded a file of this exact test. Okay. Huh?
Is this going on YouTube?
Yes.
So like we'll pick up all of this when you talk.
Yeah.
It's definitely good. Yeah, have you started already?
We start at 12.
Okay.
Yeah, no worries. Okay, guys. So it is 12 o'clock right now, so we're going to get started. Before we really get started, I did want to ask you guys, I tried to separate the questions like chapter 1, chapter 2, 3, 4, 5, 6. Do you guys want to do 6 first and then come to 1, or 1 and then go to 6? What are you guys feeling?
We can do 6 first.
6 first, because 6 is a little bit harder. 1 is like more of the easier stuff, but because we do have 2 hours, 50 questions, don't know if we'll complete it completely, but just so we can get as much information as we can. So we'll go backwards, okay? So we're going to start with number 51 first. Use the standard enthalpy of formation to calculate this equation. Okay, so usually with this equation, what is provided to us that I did not provide, which I'm going to add right now? The what? Exactly, right? The delta HF value. So I'm just going to like add that on right now. Kilojoules per mole. What are you guys expected to know for sure? There's one value we need to know for sure, like without the help of the professor providing it. That would be this value, right? This is an example. What value would that be? 0, right? Why would it be 0? Huh? Exactly, right? It's in its natural state. Okay, so now that we have those values, we're going to get started with the problem, right? And so the main formula for this problem would be the sum of the products minus the sum of the reactants. So I would set it up based on its coefficients. So I'm going to just get into it. So these are the products, these are the reactants. So 3 times negative 393.5 plus 2 times 0, which we know is just 0, minus negative 1139.7 plus 3 times negative 110.5. Okay, so we have that. Can someone help me calculate this? What do you guys get on this side? So we have 3 times negative 393.5. This is basically 0, so what is the value here? And then this side as well. So did anyone get a number for the left one right here? Okay, so I got negative 1,180.5. Is that the same consensus with everyone? Okay, awesome. And on this side, I got negative 1,471.2. Same number as everyone? Okay, so we know that a negative and a negative becomes a positive. So can someone tell me what this answer would be? Thank you. Negative 290.7 kilojoules. Does everyone agree with that? Anyone disagree with that? Okay, so we're saying, wouldn't it be positive? Would it be positive? Because we have a lower number here and we have a higher number here. So basically it's like 1,471.2 minus 1,180.5, right? So you're right, the answer will be positive. So it's just the sign. You just have to make sure you put it into the calculator correctly. Does that make sense for everyone? Yeah? Okay, so when you're typing in 1,180.5, make sure you put the negative sign in front of it and then put add. Yeah, okay, awesome. Now let's go on to the next question, Hess's law. So we know that there's 3 laws to answer this type of question. We have to manipulate these 3 equations that we see right here so we can get this. So someone tell me, what I can do to the first equation. Which compound should I manipulate? CH4, right? Okay, so I have CH4 on the reactant side here, and reactant side here, and in my first equation I have CH4 on the product side. So what happens to my delta H? Exactly, so I'm going to make it positive, 74.6. So my sign changed. Awesome. What about the second equation? Which one can I manipulate in this one? Cl2, right? Okay, so I have 2 Cl2 here, I have 4 Cl2 here. So what happens to my delta H? Times it by 2? Okay. So it would be 2 times negative 95.7. Okay, does everyone agree with that? Okay, why don't you agree with that? Okay, so in this equation, we do have 2 components that we could possibly manipulate, right? We could manipulate CCl4 or we can manipulate Cl2. What makes you decide that you want to do CCl4 instead of Cl2? Okay, that makes sense. So does that make sense to everyone? For each type of equation that you have, you want to manipulate one compound. So make sure you look through all of the equations in total before you go into it and change something. Obviously, if you make a mistake, you can go back and change it. But in this equation, the one that we focus on is Cl2, right? And in this one, we focus on CCl4. Only because they're both evident in these equations. Okay? So we have CCl4 here, we have CCl4 here, so what would happen to our delta H? Stay the same, awesome. Okay, so it'd be negative 95.7 kilojoules. Okay, and we have Cl2 here, we have 4 Cl2 here, so what would happen to our, delta H? Multiply it by 2. So everything by 2 or everything by 4? Okay, because we have a 4 Cl2 here, right? So this would need to be times by 4, right? Why would it be multiplied by 2? Yes. Right here, right? Okay, so we're not even focusing on Cl2, are we? We're focusing on HCl? Is that what you guys are telling me? Okay, so just wanted to clear that up. Awesome. So if we multiply 2 times negative 92.3 times 2, what do we get? Negative 184.6. Yes?
Which one were you focusing on in number 2?
Okay, so in the first one, we were focusing on CH4. Second one, we're focusing on CCl4. And the third one, we're focusing on HCl. You basically, okay, so in order to answer these type of questions, you kind of have to be able to think ahead of the problem. You want to be able to focus on one compound each time, or if it really confuses you, what you can do is try and write out the net ionic equation just to see that it balances out to equal this. But I tried to choose a little bit more harder problem than an easier problem you might get, which would be more straightforward, where they wouldn't put 2 compounds in one equation. Just so you guys can try and think ahead and be okay, I'll manipulate CH4 in this one, I'll manipulate CCl2 in this one. So kind of just be able to think in that manner.
Because it looks like you have CL2 in both. So.
We do have Cl2 in both, but we decided to manipulate, so here, I can better explain it like this. We have 2 Cl2 right here, right? And if I multiply the whole third equation times 2, that means this whole equation becomes 2H2 plus 2Cl2 goes to 4HCl, right? And this final equation is what I want to find delta H for. And I have 4 Cl2 here. Basically, when you add the net ionic equation for all of this, you cross things out and you add things together. I don't really mess with the 2 Cl2 here. So the 2 Cl2 there and the 2 Cl2 here will add to 4 Cl2, and that'll make the 4 Cl2 there. So what I'm trying to say is you kind of have to be able to think ahead in that manner, and if it's still confusing to you guys, definitely do more problems on that, and just kind of maybe write out the whole equation for yourself so you can see it. But that's really it. I hope it's not going to be as complicated like that, like on your final exam. Most of the times they just want to see if you guys know how to like apply the 3 laws, so they'll make it pretty straightforward. So just being able to think in that manner, like one step ahead. Okay, so we got our 3 numbers, and the last law kind of says to find delta H, we have to add them all together, right? So what do you guys get when you add 74.6 plus negative 95.7 plus negative 184.6? Negative 205.7 kilojoules. Awesome. So is that the same answer everyone else got? Yes. Okay. Okay, cool. Now let's go on to number 49. Okay, so even before I begin this problem with like a big word problem, kind of look for keywords that you're dealing with, right? So in this problem, my keyword is bomb calorimeter. For bomb calorimeter, what is my main equation I'm dealing with? Yeah, right? So Q equals cat, basically. So I'm not dealing with M here, but I'm going to be dealing with M in order to give my answer in kilojoules per mole, okay? So someone help me get started with this problem. What should I do? What do I plug in for C? Okay, so I'm going to plug in 5.86. They told me that's the heat capacity, so that's always what C is, right? So 5.86. And I'll know that my Q will end in kilojoules because that is the value they gave me right here. So be sure that you're paying attention to your units so you don't get it mixed up. Okay, and then we know the change in temperature is always T final minus T initial, right? So it'll be 29.4 minus 25.8. What do we get? Can you say it a little louder? 3.6. Okay, 3.6. Oh, no, sorry. I thought you, yeah. 3.6 is right here, yeah. So 3.6 times 5.86. What do we get? Awesome, 21.096. Okay, so that is our QCal value, right? What is another important equation that we know in order to find the delta H reaction? QCal is equal to, exactly, negative Q reaction. So whatever value you get, find the opposite, flip it. So basically, we're dealing with negative 21.096, right? Kilojoules. So in the question, they're asking me for basically delta E, which is basically asking me for delta H, because in bomb calorimeter, what stays constant? Volume, right? So basically what I'm really dealing with is just Q, because we know delta E is equal to Q plus W, Q, and we know Q is basically just delta H. Okay, so we found the kilojoules, and now we have to find the moles. What would I do now to make this over moles? Biphenol, perfect. Okay, so 0.514 grams, right? And I'm going to turn that into moles. So grams of C12H10, 1 mole of C12H10. Sorry, it's like so messy. Okay, so the molar mass for carbon is what? Yeah, right, it's 12.0 something, so I'm just gonna make it 12 just for simplicity's sake. So it'd be 12 times 12 plus, and hydrogen is usually 1 molar mass, so 10 times 1 equals, we have 10 plus 144, which is equal to 155, right? Yeah, 154, sorry. Okay, so we have 154 right here, and so what do you guys get when you do 0.514 divided by 154? Awesome, thank you. So 0.0033, right? Okay, so now this is what will give me the answers because I'm ending it in the units that they want, right? So can someone tell me what they get for the final answer when they divide it? Okay, so she said negative 63 something, right? So I'm just going to like condense it down to 6.4 times 10 to the third. Negative 6.4 times 10 to the, yeah. So usually if it's like a longer number, your answer will be given in scientific notation. So make sure you know how to go back and forth on your calculator with scientific notation. Okay, awesome. Now we're going to go to question 48. For those of you guys who just came in, we're working backwards on these questions, specifically because the end is usually like the harder type of questions, just so we can hit those before time runs out. Okay, so now we're on number 48. So it says, a 32.5 gram iron rod initially at 22.7 degrees Celsius is submerged into an unknown mass of water at 63.2 degrees Celsius in an insulated container. The final temperature of the mixture upon reaching thermal equilibrium is 59.5 degrees Celsius. What is the mass of water? Okay, so when I read this problem, what is the first formula that comes to my mind that I know I have to manipulate? Number 48. Yeah, okay, so basically I have two materials and what I'm going to be comparing is Q equals MCAT, right? So I'm going to be doing Q MCAT equals, exactly. Which one would get the negative value? The what? Okay. So the one that turns cold. I don't really think it really matters, because in the end you're really just looking for like a value usually, but just kind of conceptually understanding, one gets warmer, one gets colder. So the one that gets colder is usually the negative one. Okay, so we have the iron value, grams as 32.5. So I'm just gonna like maybe, so we can like make it a little bit more easy to understand. Grams is 32.5 grams, right, as iron, and the initial temperature is at 22.7 degrees Celsius. And so they start telling us about water, right? So I'm going to also put water's information right here. We don't know grams because they're asking us to find the mass of the water. And they tell us the initial temperature of water at 63.2 degrees Celsius. And they tell us the final temperature of the mixture at 59.5 degrees Celsius. Okay, so will water and iron have the same final temperature, or will iron have a different final temperature? Same, right? Okay, so this is what we meant when we said one gets hotter, one gets colder. So in this case scenario, iron is getting higher while water is getting colder, right? Because they have to equal each other out. Okay, so we have all of the numbers that we need except for C. So specific heat for water is always 4.18. And in this case scenario, the specific heat for iron is 0.449. I kind of just took this question from the back of the book for you guys. So usually, like in the back of the book questions, they don't provide it because they just expect you guys to go back in the book and find it. But it's just right there. You do not need to memorize that. I'd probably memorize the values for water though, just in case, because water is pretty common and it's always a solution used. And so it's a fair game. Okay, so let's plug it in. This is iron. This is water. And what we're trying to find is mass, right? So am I trying to find this M or this M? Left or right? Right, exactly. So this is exactly like what I'm trying to find in this problem. Okay, so my mass for iron is 32.5. My specific heat for iron is 0.449. And my temperature change for iron, just for simplicity's sake, it's 59.5 minus 22.7, which is, can someone tell me what that is? 36.8, thank you. And then we don't know what M is, so I'm going to leave it as that. We know the specific heat of water as 4.18, and we know the temperature change would be 59.5 minus 63.2, which is, awesome, negative 3.7. So as you guys can see, the negative and the negative are going to cancel each other out, so it's basically going to be the same answer in the end. That's why we always put a negative in front. Okay, so if we multiply all of these things together, we get 537.004. Can someone else like perform it just to make sure I did it right? Yeah. Right? Okay, awesome. And then on this side, we'll get negative M, and then 4.18 times negative 3.7, which is 15.466. Does everyone agree with that? It's the same answer everyone else got? Yes? Okay. Because I calculated ahead of time, but there is a chance I probably made a mistake. Okay, so now we just want to find M. So this is basic algebra, right? We just bring this over to the other side. This negative and a negative, when you times it together, it becomes a positive. So I'm just basically dealing with 15.466. So I have 537.004 divided by 15.466. And what is my M value? Awesome. 34.7 grams. Yes? No, you're fine. So usually when you guys get a problem like this, definitely like take it slow, separate it out for you so you don't confuse like the numbers with each other. Separate the iron, separate the water, and then just plug it in together, and it's simple. Awesome. So now number 47. Okay, so it says, consider the thermochemical equation for the combustion of acetone, the main ingredient in nail polish remover. So they give us an equation, they give us a delta H value, and the question is, if a bottle of nail polish remover contains 177 milliliters of acetone, how much heat is released by its complete combustion? Okay, and the density of acetone is, they give us a value, right? Usually whenever you see that density value, you know you're probably going to be using it, because sometimes they might give it to trick you, but most of the time they want you to do some form of dimensional analysis and conversion, right? So how could I approach this problem? What number should I start with? Yeah, exactly, right? Start with what you're given. So I have 177 ml of acetone, which is C3H6, and O, right? And what am I trying to find, really? Exactly, right? Trying to find how much is made by complete combustion. And so I can relate it to this, right? And what do we know specifically about combustion? Combustion is usually relating hydrocarbons with oxygen, and you yield carbon dioxide and water. So they kind of already gave us everything we need. Now we just need to plug and chug. So I can put the ml on the bottom, put the grams on top, so I can change whatever value I have to grams, because that's what I want to find, like you said. So I'm going to put 1 ml to 0.788, right? Okay. Now where do I go with this? What am I trying to relate it to overall? The what? Moles, right? So do I put moles on the bottom, moles on the top? On the what? Top? Okay, so 1 mole of what? Acetone, good job. Awesome. Okay, and then so grams of acetone, so let's calculate that real quick. This is calculating molar mass, C3H6O. We know that the molar mass of carbon is just straightforward 12, plus hydrogen is 1, plus oxygen is 16. So when you guys see it on your periodic table, it's going to be like 15.999. I'm just condensing it down. And I mean, you can too, just so you can like get through all of the problems on your final. Okay, so what would the answer be for the molar mass? 58? Awesome, thank you. So 58 grams is what we put in there. Okay, so we got up to there. Now what am I doing? Cool. Exactly, right? Because the whole question is asking me how much heat. So that's why they gave me a delta H value. So in the end, everything I did, I need to relate it to delta H. So you're saying related to kilojoules, right? So I'm going to need kilojoules on the top and moles on the bottom, just so I can cross this out. So what do I put in the blanks? How many moles of acetone equal a given value of delta H? Okay, so you're saying 1 mole of C3H6O equals negative 1,790 kilojoules of heat, right? So it's just, this type of question is just testing if you understood the relationship between them. If they gave me the value for oxygen instead of acetone, same process, but it would be 4 moles of oxygen to this much heat. Same thing for carbon dioxide. So just be able to kind of see that relationship. Okay, so what do you guys get as your final answer? Awesome. So I'm just going to like do the scientific notation for that. But this is what your answer would be. Cool. Okay. Any questions? Good? Okay. Okay, so number 46. The air within a piston equipped with a cylinder absorbs 565 joules of heat and expands from an initial volume of 0.1 liters to a final volume of 0.85 liters against an external pressure of 1 atm. What is the change in internal energy of the air within the piston? Okay, so this question, the last sentence is basically what the whole question's asking me, right? What is the change in internal energy? So we know the change in internal energy is E, right? And what is E equal to? Delta E equal to? Q plus W. Thank you. Q plus W. We know that Q is heat, and what is W? Work. What is the formula for W? Awesome, thank you. So in this question, you need to be able to know that formula and plug it in here so you can figure out the answer, right? So they told us that the cylinder absorbs 565 joules of heat. So what would that value fit in for? Delta E, Q, or W? Q? Okay. Would it be a positive value or a negative value? Positive. Exactly. So this is, I think, the sheet that Dr. Marcel gave you guys, so make sure you really understand that. Awesome. So we have our Q value. We're trying to find delta E. And now we're going to find our W value, right? So expands from an initial volume of 0.1 to 0.85 at an external pressure of 1. So let's just basically plug that into this formula right here. So we have an external pressure of 1, so negative 1, and the volume changes from 0.85. It goes from 0.1 to 0.85, so final minus initial is equal to, what do you guys get? Yeah, exactly. So negative 0.75. Okay, so that is what I'm going to plug in for W, negative 0.75. So my delta E would basically just be 565 minus 0.75.
Can you convert it to joules first since it's atmospheric meters?
Yeah, you're right. Does everyone see that? Okay, so let me explain that correctly. Thanks for catching it right there. Okay, so when we find W, our P, so W is equal to negative P delta V, right? Our P, what is its units? ATM, perfect. And what is our units for V? Liters, right? So whatever answer we get, like Devin said, it's going to end in ATM times liter. And just like we know, whenever we want to add things together or subtract things together, they have to be in the same units before we get the right answer, right? So if I were to convert this ATM liters to joules, it would be negative 0.75 ATM slash liters. How would I convert it? What would the conversion be? One here. Can you say it a little louder?
Yeah, so 101.3 joules to go on top.
Mm-hmm. 01.
Or 101.
Sorry. To 1 ATM L, right? Okay, and that equals?
Negative 75.975.
Okay, negative 75.975 joules. Okay, so I'll just round that to negative 76 basically. Okay, so I put that in here. It's still a negative answer, so negative 76. So what does that equal? Thank you, 489 joules. Okay, so that was a pretty important thing right there. Make sure you guys, I mean, I even said it, but I got it wrong too. So just make sure you guys are always being aware of your units, because that's an easy trip up question right there. But yeah, good job. Thank you. Okay. Okay, so now number 45. How much heat is required to warm 1.5 liters of water from 25 degrees Celsius to 100 degrees Celsius? Assume a density of 1 grams per milliliters for water. Okay, so another point I wanted to make is on all of your guys' homework questions and stuff, they always tell you the density of water, but I know on your last quiz you needed to know the density of water. That's why I kind of emphasize water values, just know it, because you just see it so much that professors expect you to know it. So if you don't see it on your final, or they don't give you the specific heat, the density, it's because they just expected you to know it. Okay, so what formula would I be plugging in for this question? Exactly. Q equals MCAT. So basically everything that we've been doing before. Okay. So it says how much heat is required to warm. So when they're asking me for heat, basically they're asking for this value, right? So always kind of like, when you read the question, know which value you're trying to find, because they can ask for any of these values. And they're saying required to warm this much liters of water from this temperature change, right? So the temperature change goes from T final minus T initial. And so what is 100 minus 25? Exactly, 75 degrees Celsius. So we know what delta T is, 75. We're dealing with water. So what would my C be? 4.18. Perfect. And now I just need an M value. Do I put in 1.5? No, right? 1.5 is given to me in liters, but they also give me a density value. So let's turn that into grams. So 1.50 liters times, okay, so what do I do here? Exactly, right? So liters on the bottom, milliliters on top. What do I put on the bottom? What do I put on the top? Exactly. And then I can just put it like that, right? So 1 to 1. So what is my value? 1,500, right? Okay, perfect. So that is what I'm going to plug in here. 1,000. And what do I get as my Q? Thank you. Okay, so I'm just going to do the scientific notation for that. So it'd be 4.7 times 10 to the 5th joules. So does everyone else agree with that? Yes? Okay, awesome. Yeah, because as you guys can see, the way we're doing these questions, it's like the harder ones first, and now it's easier, just so we can like get to those questions before time runs out. Okay, so the next question. Calculate the change in internal energy if a system releases 586 kilojoules of heat and does 112 kilojoules of work on surroundings. Okay, so someone just tell me what to plug in. 586, And negative? Okay. So what is my answer? Okay. Negative 689 kilojoules, right? Okay. So same formula that we've been dealing with all this time. Delta E equals Q plus W. This is my heat. This is my work. Whenever you're releasing heat, it's negative and it's exothermic. And whenever you're doing work on the surrounding, it's also negative and it's exothermic. So kind of just be able to know those words, easy conceptual questions right there. Okay. Number 43. Is delta E positive or negative? And is it heat or work? So for A, sweat evaporates from skin, cooling the skin. Would delta E be positive or negative? So I'm getting a positive? Yes? Okay. And would this be heat or work? Heat. Okay. B, a balloon expands against an external pressure. Will delta E be positive or negative? Positive? Okay, so I'm getting a positive. Does everyone agree with positive? Anyone think negative? What's the difference between positive and negative? What does it mean if it's a negative value? Is my system doing work or is work being done to my system? System is doing work when it's negative, right? So if a balloon is expanding against an external pressure, what would be my system? The balloon, right? So the balloon's expanding, so basically it's doing work against this, right? So it would be negative. And is this heat or work? Work, exactly. Okay, cool. An aqueous chemical reaction mixture is warmed with an external flame. Heat or work? Heat, right? Exactly. This one was pretty obvious. And then negative or positive? Okay. Does everyone agree with that? Yes. Okay. So we're going to go back to part A. And so now we're thinking it's going to be negative because it's cooling. Does anyone have any disagreements with that if I change that to negative? No? Okay, so this is how we have to see it as, right? So it's saying sweat evaporates from skin, sweat evaporates from the skin, cooling the skin, right? So in this example, which one is the system? The sweat or the skin? Skin, right? So like we said, if work is being done on the system, is it positive or negative? It's positive, right? So in this case scenario, the skin is kind of just chilling there while the sweat cools off, right? And another way how I understand it is like if you're going from solid, liquid, to a gas, this is always endothermic, and this is always exothermic. So liquid to a gas is evaporation, right? So if you just see that word evaporation right there, it would be an exothermic process, which is positive. Yes?
So the sweat evaporates from the skin into the surroundings. So is it not system doing work on the surroundings?
In this case scenario, like, it's because they add that extra statement, like cooling the skin, right? What they're trying to say is like the skin is the system. And so you just have like the basic information, like the basic definition that you guys know is like if the system does work, it's negative. If work is done on the system, it's positive. So in this case scenario, something is being lifted off of the system, right? So the system itself kind of just stays the same. It doesn't do anything. So you have to see it like that. And also, if it's still kind of like confusing, because sometimes like evaporation, condensation can be confusing, but if you know evaporation is going from liquid to gas, you can use this analogy right here. You'll understand this better when you get to Chem 2, but it's basically the same thing. So evaporation, condensation, sublimation, those kind of examples where you're dealing with heat, you can do those questions. And what do we know about combustion? Is combustion exothermic or endothermic? Exothermic, okay, so that's just like another one just to know for sure. Simple questions, awesome. Okay, so last one for chapter 6. Convert 345 kilowatts to joules. How would I do this? I would need a set up dimensional analysis, so what would go on the bottom, what would go on top? Joules on top, thank you. Thank you. Okay. Does anyone know the conversion by heart for this one? Awesome, good job, thank you guys. So it'd be 1 kilowatt equals 3.6 times 10 to the 6. So this is just one of those things you make sure you look over. So I'm just gonna like write that right here. 1 ATM-L equals 101.3 joules, and 1 kilowatt equals 3.6 times 10 to the 6 joules. So these are just some measurements. I don't know if the professor's going to give it to you guys. I would just kind of like know it, you know what I mean, just in case. Okay, so what is my answer? You can give me the scientific notation one. Let me see if I can get the answer from someone else. Yes?
1.242 times 10 to the 9.
Exactly. Thank you. Times 10 to the 9. Is that the same answer everyone else got? Because I'm kind of just asking, but I obviously calculated before I came, but just want to make sure because I'm prone to make mistakes as well. Okay. Awesome. Okay, so now we're going to go into chapter 4. So let's get started. Does anyone have any questions so far? Is everyone feeling good about the material? I can't put like every type of question like possible on this review, just because I want to hit like 3, 4, and 2 before we finish. But so far with whatever we've done, any questions? No? Good? Okay, so let's get started. 41, for the redox reaction, identify the oxidizing agent and the reducing agent. Okay, so before I get into it, what does it mean to be the oxidizing agent? It's being reduced, right? So it's another name for it. And what does it mean to be reduced? Is it becoming more positive or more negative? More negative, perfect. More negative, and it's gaining more electrons, like you said. Okay, and then we know the reducing agent. What's another name for that? What's another name for reducing agent? Exactly. Oxidized, and it's becoming the opposite, more positive. Okay, so these type of questions, they can ask you identify the oxidized or identify what's being reduced, so just kind of know the difference. They are opposites of each other. Okay, so in order to answer this question, I need to find the oxidation state of everything, right? And then I can compare the oxidation state to see which one gets more positive, which one gets more negative. So let's do part A first. The oxidation state for lithium itself, which one would it be? 0, right? Do you know what oxidation state rule that is? Rule 1, right? So this is another thing, like, just make sure you guys look over. Make sure you guys look over the sheet, the energy sheet, and make sure you look over the oxidation rules, because most likely they will not be provided. Okay, so we know that lithium itself is 0. What about O2? 0? Yeah, right? It's elements, free elements by their self-natural state. Okay. What about Li2O? This one is a compound, right? So I'm going to have to manipulate it a little bit to find what the oxidation states are. So what can I do to find it? I can set it up, right? So what would this whole compound's oxidation state be equal to? 0, right? Awesome. So that is an oxidation state rule. If I had a charge, like for example, if I had Li2O -3, what would the oxidation state be equal to? -3. So just kind of know, like, your charge affects what your oxidation state is equal to. Okay, so I have 4 lithiums and I have 2 oxygens in this compound, and that equals all to 0. Now I can plug in the Li values and the oxygen values. So what would my Li value be? +1, and my oxygen value would be -2. Okay, so in order to find these values, once again, it's those rules. Go by priority of the rules. So whichever rule has, like, higher up. I know lithium is like group 1A element, and it's a higher rule. So that's why you would give lithium the +1 before you give oxygen the -2. So just kind of know that. Because there are instances, if you gave oxygen first, and for example, lithium was there, it would give lithium another number, but lithium has priority. Okay, so we found +1 for lithium, and oxygen is -2. So obviously we see some changes, right? Lithium goes from 0 to 1, and oxygen goes from 0 to -2. So what is my oxidizing agent? Oxygen, right? Perfect. And what is my reducing agent? Lithium. Awesome. Okay, so when I am doing these type of questions and they ask me, like, what is the agent or what is being oxidized, give the answer regarding the reactants, okay? And if they're asking, like, the specific element, like if you're dealing with larger compounds, then give the element. But usually you're dealing with whatever changed in the reactants. Okay. This question. Okay, so Mg plus Fe2 plus goes to Mg2 plus and Fe. Simple question. What would the oxidation state for Mg be? 0. Perfect. What about Fe2 plus? +2, right? So this is another oxidation state rule. Wherever you see an element, like a free element, but a charge is given to it, this means this is an element with more than one type of charge, right? And we have a list of that as well. So make sure you guys look over that list as well, because that will come in handy when you're naming ionic compounds. Okay, so we have +2 right here, and so what would Mg2 plus be? +2, thank you. And then Fe itself would be 0. So here again we see some changes. We're going from 0 to 2, and then from 2 to 0. So what is my oxidizing agent and reducing agent? Iron. Perfect. So like we said, oxidizing agent is the value that gets more positive, right? No, wait, gets more negative. So it's going from 2 to 0, a more negative number, and then reducing agent, answer that gets more positive, going from 0 to 2. Okay. So it's just an easy way of looking at it and understanding it. Any questions? Anyone? And another question is, like, if you are given a more complex equation, set it up in a way where you find the polyatomic ion and you equal the whole charge to the polyatomic ion. So I'm just going to give, like, a quick example right here. Like if I had KNO3 minus, basically K plus, right? KNO3. So NO3 should, this whole thing should equal -1 as its oxidation state. Does that make sense to everyone? So I wanted to put simple problems on here just in case if people didn't really, like, understand it in general. But that's how you would set up that kind of problem. So you would have to, we know 3, let's just, like, do that right now. What would the oxidation state for oxygen be? -2, right? Because that's another oxidation state rule. So it'd be dash plus -6 equals -1, so what would the nitrogen's value be? It would be 5. Okay, because it would be like 5 minus 6 equals -1. So I kind of just like did this one to the side. This is regarding like if you have more complex equations. These ones were pretty simple, straightforward. But if you have more complex ones, just kind of know that when you're dealing with polyatomic ions, your charge or your oxidation state equals the charge of those polyatomic ions. Okay, so balancing gas evolution equation. Okay, so another thing to memorize or another thing to know. There are certain examples of products that can form when you balance your equations, and you have to know when that will be a gas and when you can break down those gases. So make sure you look over that list. I know it's in the PowerPoint. In my question right here, I do give a specific example, but there are, I think, like 3 other examples. So kind of just be aware of those questions so you know how to answer them. Okay, so when we are balancing, one second. When we're balancing like equations in general, what are we trying to do when we balance equations? We match the positive with the negative, and we match the negative with the positive. So you try to match it on different sides, right? So let's break up HNO3. It would break up into H plus and NO3 minus, polyatomic ion. We have Na2SO3, right? What would it break up into? So it would break up into Na plus, and then SO3, 2 minus, okay? So in the beginning, when you're setting these questions up, don't worry about having to balance the equation. Like, for example, there's 2 sodiums, right? I'm not going to put a 2 right in front of it right now. Just focus on separating them up, and then you can balance it afterwards. So like we said, the positive matches with the negative matches with the positive, right? So it'll be H2SO3. So does everyone see why I put 2 hydrogens? Because I have a -2 value here and a plus here, so you need 2 hydrogens to balance out with sulfide value. Okay, so H2SO3 plus NaNO3. Does everyone agree with that? Yes? Okay. So am I done here? Did I balance the equation? No, right? So especially like even in this question, I kind of gave it away saying gas evolution equation, right? So even before I balance it, what do I do? Exactly. So even before you balance it, you have to break this value down. So this is why I was saying there is a chart of certain gas evolution products that you need to memorize into what they break down into. So what does H2SO3 break down into? Exactly. Thank you. So same process, but you just have to go that extra step. Plus NaNO3. So I'm just rewriting the whole equation here. Now can I balance the equation? Yes or no? Yes, okay? So I set it up accordingly. I broke down like the gas. Now I can balance the equation. So what do you guys think I should do to balance this equation? What should I type in first? Or put in first in front of like a molecule? Because the whole idea of balancing equations is same amount of hydrogens on the left side, same amount of hydrogens on the right side, right? So we just want to make sure everything is equal to each other. So usually when I start with these kind of questions, a good way to go is focus on your more complex compounds, right? So in this case scenario, maybe I can focus on this one. This one looks pretty complex, right? So I have 2 sodiums, 1 sulfur, and 3 oxygens. So if I have 2 sodiums on this side, I only have 1 sodium on this side, so let's add a 2 there. So now I have 2 sodiums, right? And so now kind of like everything kind of changes as well, right? Now I have 2 sodiums, 2 nitrogens, and 6 plus 2 is 8. 8 plus 1 is 9 oxygens, right? And I have 6 oxygens here, and I only have 1 hydrogen here and 1 nitrogen here. But since I have 2 nitrogens here now I'm going to add a 2 right here. Okay? So what I would say is start with your more complex one and then try and balance the complex one and kind of go to the next one from that. So now let's look at it. Now we have 2 hydrogens. How many hydrogens do we have on this side? We just have 2 hydrogens. Nitrogens, we only have 2 nitrogens. On this side, we have 2 nitrogens. We have 2 times 3 is 6. 6 plus 3 is 9. 9 oxygens. On this one, we have 1 plus 2 is 3. 3 plus 2 times 3 is 6. 9 oxygens. So everything kind of looks the same. And the last one I'm missing, I think, or I think I'm missing sulfur and sodium. But basically, I have 2 NAs, 2 Na, 1 S, and 1 S. So now I know I really balanced my equation. And balancing equation kind of like trips you guys up, and like you feel like you don't really have that much time, because it really is kind of like, I wouldn't say like a guessing game. Obviously, you start with the more complex one, but it does take time. So if you see it on an exam and you know that you don't really feel comfortable with it, your exam is multiple choice, so you can just look through your multiple choice. They won't give you more than one correct answer of balanced equations on both sides. They could do that for you, like in this case scenario, if they didn't break this down. So break it down first, and then make sure everything is balanced on both sides. So it's basically as simple as that. Okay? Awesome. Okay, now we have another question regarding balancing the equation, but it's saying balance the acid-base reaction. Okay. So, same idea, right? What does HCl break down into? H plus and Cl minus. What does BaOH2 break down into? Can I get, like, I want some more of you guys to participate, and like, can you guys like speak up? Because I'm trying to like talk loud, and like I'm starting to like feel a little sick, and we have to keep going for 1 more hour, so I just want you guys to like just try with me. So BaOH2, what does it break down into? Thank you. Ba2 plus and OH, right? OH minus. Another polyatomic ion, make sure you know it. Okay, so same idea right here. Plus goes with minus, minus goes with plus, right? So what would I have on my products? Thank you. Yeah. H2O plus BaCl, right? Is it like this, or do I add something else? 2, exactly. So this is like basic chapter 1, chapter 2, so everything kind of like clicks now, right? So kind of just like know that. Okay, so we balanced the equation. Let me see if there's anything else that I wanted you guys to do specifically. Yeah, so we basically found the opposites, right? But is the equation balanced? No, right? Exactly, I have 1 chlorine here, I have 2 chlorines here, I have 2 hydrogens here, 3 hydrogens here. Okay, so how can I balance this? What can I focus on first to balance this equation? Focus on what? Chlorine. Okay, so I have 2 chlorines here, right? And I only have 1 chlorine here, so you're right. Let's focus on chlorine. Let's add a 2 in front of the HCl plus Ba. So I'm just going to rewrite it for us. H2O plus BaCl2. Okay, so now I have a total of 4 hydrogens. I still have only 2 hydrogens on this side, but I do have the same amount of chlorines now, right? So now what should I focus on? 2 what? 2 in front of the hydrogen. Okay, so because we have 4 hydrogens on this side, let's add a 2 here so we can make 4. So now I have 4 hydrogens on this side, 2 oxygens, 1 Ba, and 2 Cl, right? Let's look on this side, 2 hydrogens. Wait. I have 2 hydrogens, but I also have 2 hydrogens here, so I'd have 4 hydrogens, 2 Cl, 1 Ba, and 2 oxygens. So even though this is like a polyatomic ion, I broke it down into its oxygen and hydrogen value, because when you're focusing on balancing the equation, you're really focusing on the element itself, okay? So does that click for everyone? Yes? Okay, awesome. And if you guys are just kind of like walking in, and if you also like don't know like what I'm looking at, like where the paper is, just go on to UCF Study Union 2018, click on the website, and if you just click on chemistry, the PDF is uploaded on there. Okay. So now number 38. Write the complete net and ionic equation. Okay, so before we even get started, what is the difference between the net and the ionic equation? The net ionic and the ionic equation. Does anyone know like the definition between the difference between them? Yes?
The complete one is when you have all of the ionic, and the net one
Awesome. So you're right? Like the net ionic is when you've canceled those certain ions out. So the ions that you cancel out, what are they called? Spectator ions, right? So that's a good question as well. He could just ask you guys to balance the equation and then just ask you what are the spectator ions. So those are the things that you're crossing out because you don't need it because they're on both sides. Okay, so let's do that right now. So same process here, right? Break down the equation. Break down each compound. NaOH breaks down into Na plus and OH minus. HC2H3O2, what does it break down into? H plus and C2H3O2 minus, right? What is this polyatomic ion? What is the name of it? Acetate? Yes. Okay. So just know that because I think some freebie questions would be like him just giving you a polyatomic ion and asking you what is the name of this polyatomic ion, right? Okay. So that breaks down into what would H2O break down into? H plus and OH. Does everyone agree with that? Yeah? Exactly, right? So just like when you are breaking down the equations, make sure you know that liquid and solid don't break down. So an easy way is on all of these questions, especially if they're tests, they're always written nicely. If it's AQ, it breaks down, right? If it's a liquid, don't break it down. AQ, it breaks down. Solid, precipitate, don't break it down. Just like that. Okay, good job. Okay, so H2O, and then, let's see, we have NaC2H3O2. What does that break down into? Exactly. Thank you. Na plus C2H3O2 minus. Okay. So now that we have that, what would this value be? Like all of this? Is this our net ionic equation or the ionic equation? It's the what? It's the ionic equation, right? So I'm just going to write that right here. Ionic equation. Okay, so we already basically discussed that spectator ions are things that are present on both sides and things that we can cross out, right? So we can get our net ionic equation. So what are my spectator ions in this equation? Sodium. Okay, sodium. What else? So acetate. Anything else I can break? No, right? Okay, so then my ionic equation net ionic equation will basically be everything that's left over. So I have OH minus plus H plus goes to H2O. So just to make sure you're on the right track, if your answer comes out pretty and it matches on both sides, you're right. If you cross something out and you weren't supposed to, and it doesn't turn out like perfect on both sides, then you're probably wrong. Okay. Feel good with this question? Because I think that was like on your test as well, right? And on your quiz. So definitely know how to do it. It's an easy question to be tested on, especially like finding the spectator ions, because people always kind of like forget the definition of spectator ions, and that it means the ones that you cross out and not the ones that stay. And those are usually like really good test questions. Okay. So, yes? Okay, so we discussed that before, right? So if it says like a liquid, so usually you'll have the state of matter written on it. So if it's AQ, which means aqueous, it breaks down. If it's a liquid or a solid, don't break it down. Okay. Yeah, no problem. Okay, so number 37. Write the molecular equation. Is it a reaction or no reaction? So they give me two compounds, right? So what does that question mean? Reaction or no reaction? If there's a reaction, what is present in my equation? Just so like, because when you read your questions, you should be able to kind of have an idea of what you're looking for before you even like get into it, right? So if there is a reaction, what does that mean? It usually means that there's a precipitate present. So a precipitate is what state of matter? Solid, right? Exactly. So basically what they're asking me is combine these two compounds together, is there a solid? So what question is, like what topic is this type of question hitting at? Your solubility rules, exactly. So this is where you need to know your solubility rules. So it's kind of like one thing on top of the other, all the things you have to memorize. But let's see. Yeah. So strontium nitrate, how would that be written out? So this is the type of question where they want to know if you remember how to name ionic compounds and how to kind of go back and forwards on it. So strontium nitrate would be written as what? SR. Okay, so NO3. So what do we know is, based on the periodic table, what group is strontium in? Group 2, right? So if strontium is in group 2, what is strontium's charge? 2 plus. What is nitrate's charge? -1. So what happens here? 2 right here, okay? So kind of just know that you have to set it up like that. And potassium iodide. So potassium, what letter is it? K. Iodide, what letter is it? I, right? So we know that K has a charge of +1. I has a charge of -1. Perfect. So it's like left the way it is. Okay, so we figured out the question. Now we have to find the molecular equation, right? So same thing right here. Break it down and balance it out, right? Okay, so basically the positive is going with the negative is going with the positive, so what will my products be? Potassium nitrate, thank you, KNO3, plus what? Okay, potassium nitrate and, okay, so strontium, yes. Strontium iodide 2. Perfect, thank you. Okay, so the good thing is, so we discussed already like what it means, whether it's a reaction or not, right? So now what do we need to do in order to determine if it's a reaction or not? Determine if it's soluble. So if the value is soluble, there will be no reaction. If it's not soluble, meaning that a precipitate forms, there will be a reaction. So you look at your products, KNO3, SRI2, are any of these like non-soluble together? Does anyone have their solubility rules with them, or like?
They're both soluble.
Okay, so they're both soluble. And I believe it's kind of like NO3 has no exceptions, and SR I think has like a few exceptions, but I doesn't make the cut. So these both are soluble, so is there a reaction or no? No reaction. Cool. Everyone feel comfortable with that? Basic solubility rules. I wouldn't say like memorize the whole chart, but kind of like, especially like the ones that have no exceptions, just know those ones, because you don't really have to memorize those ones. Like I know NO3 is one of those examples that have no exceptions. That's an easy memorization right there. Okay. So soluble or insoluble compound, same thing. Oh, it's a little. Okay, so AgNO3, is that a soluble compound or an insoluble compound? Soluble. Perfect. What about PB, lead to acetate? Soluble. Okay, so so NO3 we said has no exceptions, and another example of no exception is acetate. So whenever you see acetate with any element, just know that it's soluble with everything. Awesome. And then cobalt carbonate, soluble or insoluble? Insoluble? Okay. So like I said, this is your guys' solubility rules. Carbonate is only soluble with certain materials like lithium, sodium, potassium, and I think ammonia, but it's not soluble with cobalt. So yeah, that's kind of how you can memorize it, I guess, like kind of like know the compound and then know like the 4 different things that it's usually like soluble with if it's insoluble in general. Okay. So we have like, let's see, we have like around 42 more minutes. We do have to end, I think, like 10 to 15 minutes early because I do have to give you guys surveys and I ask last minute questions and we can talk about study tips. But let's see. I I will definitely post the answers online, and I'll post it on my WordPress and maybe post it on the announcements so you guys have access to it. But if you guys have access to the packet right now, is there any questions that you really want to go over, like for us to talk through right now? Only because like we're halfway through, and I want to make sure I hit some of those questions like before we leave. So I'll give you guys like 1 minute just to look through. If not, we'll start at 35. Yes.
Can you do the stuff for like renaming ionic and molecular compounds?
Yeah, so that's like chapter 3, right? Yeah. So is that okay with everyone if we go straight to the naming ionic and molecular compounds? Yes.
Number 33 or 35?
Number 35? Okay. 33 or 35. Okay, so what we'll do is, since I'm already on this page, let's do number 35, and then we'll flip back to like chapter 2, just so we can get to some of the molecular and ionic compound questions, just so we make sure we hit it before we leave, right? Okay, so consider the precipitation reaction. They give us a big equation right here, and they say, what volume of 0.175 molarity Na3PO4 solution is necessary to completely react with 95.4 ml of 0.102 molarity CuCl2. Okay, so I remember like when we had these questions on your guys' quizzes, it looks like a lot, it's a handful, the question itself has like 3 different numbers in it, right? So what can I do to break this down for me, just to make it a little bit easier? With the numbers I'm given, what can I do? Yes? Okay, so we have an approach here, M1 V1 equals M2 V2. Do you guys think this is the formula that we're going to be using for this equation?
No, you usually use that one only if you're working with the same, like, or like the same element. Like,
Okay.
So like we use that for number 34, but not for 35.
Okay. So did everyone hear what he said? So kind of just be aware of that, because there are 2 formulas that you're dealing with when you're dealing with stoichiometry problems like this. And like Devin said, when you're dealing with one main like stock solution, that's when you will apply this formula, okay? But when you have like a complex equation like this, what is the formula that I'm focused on? It's M equals N over V. N of what? Moles, and V in what? Liters. And this is molarity. Perfect. Okay. So definitely this is a pretty important like differentiation. How I usually see it is like if it looks too complex, this formula is way too easy for it. That's how I see it. And if it's a simple question, like giving me like 2 variables, 3 variables, but it's like straightforwardly stated, then I'm going to use this. Okay? Okay, so let's do number 35. So usually like how I like to approach this problem, I'm just going to rewrite it right here only because so you guys can see like how I like to do it. I try to break it up so it makes more sense, because when you read it all in one question, they all jumble together, right? So it says volume of 0.175 molarity of Na3PO4, right? So this has a molarity of 0.175 m. Is necessary, so they want us to find volume of this. Completely react with 95.4 ml of CuCl2 at a molarity of 0.102 m. Okay, so this is basically what they're asking me. They gave me 3 values and they want me to find V. So I understand like why we would want to like apply this, right? Because it would be like easy just to like plug and chug this question in. But does anyone have like a better reason as to why we wouldn't use this formula and why we would use this approach? Any reasoning like behind that? Yes. That's good. Yeah. So usually, like I kept saying, like it's just more complex. It's more complex. But if you really want to understand the reason behind it, is exactly they have different amount of moles. So here you see 2 moles of this, 3 moles of this, 1 mole of that, 6 moles of that. Here you're just dealing with one solution and like 1 mole of it. So this is a very straightforward equation, right? If you plug that in here, you're basically telling me all of this is 1, or you're trying to you're basically simplifying it down to something that's not as simple as it actually is. Okay, so good. So how can I approach this problem? What should I start with so I can find the volume for this? Start with CuCl, right? Because CuCl, they gave me everything I need. We start with CuCl and we can find something and relate it to Na3PO4. So should I start with the molarity of CuCl or the volume of CuCl? I'll just start with the volume, okay? So in order just to make it like a little bit easier for me, actually no, in order just to make it a little bit easier, your molarity formula is always like in moles and liters, right? So I'm just going to change that to liters real quick. So you just have to move it over 3 positions, 1, 2, 3. So it'll be 0.0954 liters. Does that make sense to everyone? Just so you're dealing with like the right units and stuff, okay? So same number, just a different unit. 0.0954 liters of CuCl2, right? Okay. What do I put on the bottom? What do I put on the top? My whole goal is to find V, so I need to find a way to relate whatever I have here to this. What can I put on the bottom? What can I put on the top? Another value I have is the molarity value right here, right? So how can I set it up for myself? Usually they give you something, they kind of want you to use it.
I don't know. Like, can't you just do the liters multiplied by the molarity to get in, like in moles, and convert it to Na3PO4?
I see what you're saying. I just kind of like want to break it down so everyone kind of like understand, like they can cross it out as they're going. Do you know what I mean?
Yeah.
Yes. Okay, so yeah, so are you saying like put liters right here? Is that what you're saying, or? Okay, so how I would approach this problem is they gave me my molarity value, right? And so here we already wrote the formula for molarity. It's moles over liters, right? And basically M is just 0.10 mole over 1 liter, because whatever value divided by 1 is the same value, right? So you apply that here. Does that make sense to everyone? Just, you have to kind of like be able to see it in that perspective. It means the same thing, I'm just writing it a different way. So now I'm able to relate moles. Moles is how we relate things to each other, right? That's how we've been doing it like throughout this whole class. So whenever you want to find a way to relate something to something, first change it to moles, then go to what you need to do. Okay, so we found the moles of CuCl2. Now what can I do? I'm just going to erase this right here so it's not confusing. Yes?
How did you get moles from molarity?
Okay, so let's break that down, right? So in the question, they told us that CuCl2 has a 0.102 molarity, right? We know, what is the formula for molarity? It's N divided by V, right? So it's moles divided by liters. So it's basically like me telling you like, oh, I'm giving you 3 molarity. 3 is the same as 3 divided by 1.
But in order to get the moles, did you not do molarity multiplied by the volume?
It's the same process. So let me see if I can, I know what you're saying. Basically what she's saying is M is equal to N divided by V, right? So I can do M times V equals N, which is basically, it would just be 0.102 moles over 1 liter. So it's just 1 times 0.102 equals 0.102. What I'm saying is like 3 molarity is basically 3 moles over 1 liter. Does that make sense to everyone? You just kind of have to, it's a division factor. Like, so if I had 2 molarity, if I could put 4 or 1, I could put 4, no, I could put 4 and 2. It's just the idea that you have to be able to expand that idea. That's why we have the formula written right here, saying that they're the same thing. Does that make sense to everyone? Okay. I'm just going to erase these extra stuff so it doesn't look confusing. Okay, so yeah, so we use the volume, we use the molarity value because they gave it, and we set it up in a way that we could actually use it, right? So now we can compare moles of CuCl2 to moles of Na3PO4. What can I put on the bottom? What can I put on the top? How can I relate the moles? Exactly, right? Because that's given to me in the equation, 2 and 3. So usually, like, in these kind of questions, they do balance it before they give it to you, but just in case, I guess check, you know what I mean? Just in case you don't get it wrong. Yes? Can you say that a little louder? Sorry.
When do you get to use that 0.0954 liters?
0.0954 liters. Yeah, so I use that just so I can relate, like, because these two values are related to each other, right? They're for the same compound, right? So what I did was I kind of like took the liquid and I'm turning it to moles, and then from moles, then I can relate it to Na3PO4, because that's what I really want to find. All I did was change the ml to liters. It's the same value. Yeah, so in order to get it like that, I just divided it by 1,000 to turn it into liters, and I know that moles over liters equals molarity, right? So I'm kind of like utilizing this molarity value right here so I can find the volume of this. But I will be utilizing this at some point. Does that make sense? Yeah, I see what you're saying, yeah. Okay, so now I have the 2 moles of Na3PO4 to 3 moles of CuCl2, right? Now what do I do? In order to find the volume. What I put on the bottom, what I put on the top. Okay, so yeah, so now you're saying that I have to use this value, right? So same thing as what we talked about before. 0.175 molarity is the same as 0.175 moles over 1 liter. Does that make sense to everyone? So basically what I would be doing is 0.175 moles of Na3PO4 to 1 liter. And now I'm at a volume value that I want to find. So you have to set it up in that manner, and if it's kind of like confusing, try and find a pattern for yourself in order to answer these kind of questions. I remember when I was first doing it, like I wouldn't know how to get from one place to another, but I kind of like memorized patterns to help me figure it out, right? So first thing would be break it down. Second thing, usually use what variables you're really given. This side, I was really given like a lot of variables, right? So I use it first, I use it completely before I even approach this side and I relate it. Okay, so now I have my value in liters, right? So I could leave my answer in liters, but usually if your other answer, like we have CuCl2, it's given in milliliters, right? So make sure you change it to milliliters then. Kind of just focus on what the other answers look like and keep it similar. So from here we can change to milliliters to liters. We have 1,000. So what would be my final answer? It would be like this whole thing right here. It would be, someone tell me what they get. Yes? Okay, so 35.85. Is that the same answer that everyone got? 35.85? Yes? Okay, then I'm going to move forward because it really is just plugging and chugging into the calculator. So if it's the same answer everyone got, we're going to go for it. Okay, so do you guys want to go now to the ionic and covalent compounds or quickly answer 34? Let's just answer 34 because we kind of like talked about it in general. So you got 37?
I got 37.
Okay, so I'll change it. 37. Okay, so it's just like a calculation error. So 37.1, yeah. Okay, so let's see. To what value should you dilute 50 ml of a 12 molarity stock hydrogen nitrate, not just nitric acid, solution to obtain a 0.1 molarity HNO3 solution, right? So here I'm dealing with one solution, one stock solution, right? And here I can make the simple formula like this. I don't have to worry about having to relate it moles-wise. I don't have to make it complex like this question. Okay, so let's plug and chug, right? So they give us these two, and they give us this value, and they want us to find volume. So what do I do? Someone just tell me, because it's like really simple. Like, what do I multiply together? Okay, 12 times 50. Just kind of know that you're dealing with ml, just so, because you need to know that your answer will also be in ml. Okay. And then what would be on this side? 0.100 m, right? So we want to find V, and so what would our V be? 6,000? Is that the same answer everyone got? Yeah? Okay. Yeah, and if you change it to liters, it would just be 6 liters. Okay, so same thing. So in these type of questions, you can leave it with whichever one you want. But if you're kind of like scared, like if you don't change it, because I know in some scenarios you do have to change the units, in some scenarios you don't have to change the units. But if you're worried like you might get your answer wrong because you don't change it, just change it, like, and then you can change it back if you need it in ml. Okay. Okay, so now let's go to some of the ionic and covalent. See if I can find it. Okay. Okay, so I think like the first ionic and covalent starts at number 19. We can do, yeah, let's just start with number 15, right? And then let's do like, we'll do 15 to 23 because that's like most of the naming questions, okay? So, number 15, is the element atomic or molecular? Neon. Atomic or molecular? What do you guys think? Okay, so what is the difference between an atomic and molecular? Atomic would be 1, while molecular would be more than 1. So molecular would involve diatomic elements, molecular would involve polyatomic elements. So you kind of just have to know the difference between those ones. And I know like we determined that the diatomic elements, based on like what we learned, are never have fear of ice cold beer. These 1, 2, 3, 4, 5, 6, 7. 7 elements are the diatomic elements. And what are the polyatomic elements? Does anyone know it on the top of their heads? Thank you. And SE? Thank you. So phosphorus, sulfur, and selenium. Do you know the little numbers that go with them? Or it's okay if you don't know it. You have it? Like, I think it's like S8, P4, you know what I mean? Like, okay, yeah, I don't know for sure either, so I'm not gonna like say it just in case if it's wrong, but I think S is 8. But basically just, I guess, like look over those just in case. But I really think like if he really wants you to like know, he probably just wants you to be able to differentiate between them. Okay, so neon. As long as your element is not one of these elements, it will be atomic, right? So is neon one of these elements? No, so it'd be atomic. What about fluorine? Yes, right? It'll be molecular, and sulfur, molecular. Perfect, okay. Number 16, ionic or molecular compounds. This is going like way back to like the beginning, right? So how would we define an ionic compound? It is a non-metal and metal. Thank you. And a molecular compound is what and what? 2 nonmetals, right? Thank you. Non-metal and non-metal. So you will always have your periodic table with you. You're going to be finding a lot of formula mass during this test. So you just kind of like look on both sides. Usually all the way to the left is your metals, all the way to the right is your non-metals, and then you have like your metalloids in the middle, right? So NiCl2, ionic compound or molecular compound? Ionic, right? Thank you. Because we have our metal as nickel and our non-metal as chlorine. Okay, so SO3, ionic compound or molecular compound? Molecular. Awesome. Thank you. Okay, so because S, sulfur, and oxygen are both nonmetals, right? Okay, number 17. Write the ionic formula between aluminum and oxygen. So in order to answer these kind of questions, we know it's ionic because it's a nonmetal and a metal. No, a metal and a nonmetal, right? In order to answer these kind of questions, you got to first find the charge for each element and then just interchange, right? So what is the charge for aluminum? 3+, right? So kind of know that. On your periodic table, it's not really given to you, it's not stated, but you know it. Okay, so oxygen. What is your value? -2. And so you'd interchange them as 2 and 3, okay? Okay, guys, I'm just gonna take like a little break just for like to get some water, if that's okay with you guys. Can we take like maybe like a 1-minute break, and then we'll get back on track. Okay. Definitely like look through the packet and like we can start, you guys can like start picking random questions if you guys want to start doing that. Thank you.
You know what you're doing, right?
For the most part. Depends on what you're asking.
For what she was doing on 35, why wasn't she using
Okay, so don't follow her back and forth. Like whenever she doesn't have it, it's too easy. Just plug in the stuff back into the formula and present it with you. Something like that. But that was the right. She did the math. It was really confusing. Let me show you how I did it. So I started with M equals N over V, and I plugged in what we have for the other substance, and we started with the moles, and then we do a stoichiometry conversion to get the moles of the other substance, and then since we have the moles of that substance, and we have the molarity, then we can plug that back into the M equals N over V to get volume.
So, because I got what you got when you had the 1.00970.
Yeah, this was the stoichiometry. This is a stoichiometry conversion method. So we looked at our equation here, and we wanted to get it from moles of CuCl2 to moles of NO3AO4. So to do that, we just get the coefficients in front, put it on over there, and we get the coefficient of that one put on the bottom. And then get that, and then probably.
And I have no idea what she's doing with like the molarity.
Oh no, that was really so I just like so now we can fix that.
Oh, so then yeah, okay, so I delete that.
Yeah. I was just consistently bad. I got like 70 on the first one, 68 left time on the second one. If it's a metalloid, and we have like a metalloid and a non-metal, would that be ionic?
Usually they won't give you a question like that because that's just like really weird, you know what I mean?
Yeah.
But yes, it would be like the non-metal and metal, so it'd be ionic, yeah.
Okay.
See it like that, yeah. Okay, so sorry guys for the small break, but let's get back on track. Do you guys want to continue on forward with like 18, 19, and 20, or is there any other questions you guys want me to like do? Let's continue. Okay, awesome. So write the formula between lithium and the polyatomic ion, right? So lithium is Li. What is the charge for lithium? +1, right? So we would know this based on our periodic table. Yes.
For 17, do you put the charges when you're writing like ionic formulas?
What do you, I mean, I wrote the charges just so we knew like how we would separate them.
Oh, I mean like Al2O3.
Yes,
I thought it was one.
definitely, yeah. Does that make sense to everyone? Because you need like 2 ALs and 3 Os just so they balance out. So you definitely have to write that out. That's why you need to know the charges for both of them. Okay, so let's see. For this question, we are on number. Okay, so how would hydrogen phosphate look? Okay, so in order to answer this kind of question, you would have to know like how it's phrased or like how it looks, right? So I don't know if this was on your guys' chart, because I know he gave you a list of polyatomic ions to know, but this is a pretty important one, so even if it's not on it, I'd probably just know it just in case. Hydrogen phosphate, right? So now that I have the charge, same thing that I did right here, right? Where you interchange them, so let's do that. LiHPO4, and then where do I add? Like, what do I do to this answer?
Lithium is going to have a base 2.
Yeah, so, right? So I would, exactly. So switch. Perfect. Okay, so same question here, right? Now I'm dealing with acetate. So I have lithium, which is Li+. How does acetate look? Thank you. C2, bless you. C2H3O2 negative charge, right? So once again, flip it, and it would become LiC2H3O2. So that would be the answer. Okay, so does everyone agree with that? Make sense? Okay. So it's basically ionic, molecular, but now you're dealing with like polyatomic. Okay, so number 19. Name the ionic compound. Okay, so when we're naming ionic compounds, how many types do we have that we learned like when we took that test? We have 2 types, right? So the first type is the one that has like only one charge to it. The second type, because metals can have more than one type of charge, right? And those are usually our transition metals, and there's a list that I know he gave you guys for those different ones. I don't know if Hg is on it, but Hg is an example of the type 2 metal, because Hg has more than one type of charge, right? So Hg, its name is mercury, So it'll be mercury. What would go in my brackets for this one? What Roman numeral? 2? Okay. And how would I end it? Say it a little louder, sorry. Bromide, awesome. So exactly. So basically you keep the first word as it is, add the charge if it's a type 2 metal, and the "ide" at the end of the anion, or the non-metal part, right? Okay, now we have Ki. What would that be called? Thank you. Potassium iodide. So same idea here. Potassium, however, is only a type 1 metal, meaning it has only one charge, so you don't have to worry about the brackets right here, and IDE for the ending. Perfect. Okay. Now we have FeOH3, right? So OH is a polyatomic ion. How would I name this? Iron what? Iron 3 hydroxide. Perfect. Thank you. So same idea here. Group them all together whenever you see the polyatomic ion and just give the name of the polyatomic ion itself. You don't have to like change the "ide" or, you know what I mean, like change anything. Yes? Sure. Did you, just because like I know I already like said it, does anyone want to do like the molecular compounds first before we go into number 33, or like are you guys fine?
Do you have questions on here about like, there's a different one, and it's not the molecular one that I'm thinking of.
Okay. So I guess like since no one,
Acid.
yeah, there are acids, I think like number 22. So do you guys want to do like that first because it's the same topic, and then we'll go to number 33, is that okay? Okay. Definitely we'll hit that, okay. So let's see. Number 22, name the acid. HI, what would the name of that acid be? It would be hydroiodic acid. Does everyone agree with that? Yeah? Yeah, it's right. Okay, cool. Because if it was HF, you know, it's hydrofluoric acid, HCl, hydrochloric acid. So sometimes if you get like kind of confused related to the things that you do know, I know we all know like HCl, right? Okay, so HNO3. Okay, so what is the polyatomic ion we're dealing with here? Nitrate, right? And so this is one of those things we learned in class where the ending turns into what? What does 8 turn into? Ic. Perfect. So what would the name of this acid be? Nitric acid. Thank you so much. Okay, same thing here, right? So whenever you see an H with a polyatomic ion, name the polyatomic ion, look at the ending, and then determine how that will change the name of your acid, right? So we have ClO2 here, which, what is the name for ClO2? Chlorite. You're right. Thank you. ITE turns to what? Us, right? OUS. So what is the name of this acid?
So then why is A?
Okay, so would it be hydrochlorous acid or chlorous acid? Chlorous? Okay, so let's clear that up, right? Why are we, wait, let me type this correctly. Chlorous acid. So why am I not including hydro in it? Because there's oxygen. Perfect. So if you guys look through your textbook, there is a diagram of how to name like acids and ionic and molecular, right? So if your acid has an oxygen in it, which these two do have, most polyatomic ions have at least like one oxygen in it, you do not include the hydro in front of it. If it has no oxygen, it's known as a binary acid, and you do include the hydro in front of it. So binary acid, common examples, HCl, HI, HF, HBr, such and such. Yes?
So why is A the way that it is? Because you have IC.
A?
Yeah.
Okay, because why is A, why did I name it hydroiodic acid after like what I said? There's no oxygen.
No, the hydro's fine, but like why did you put IC?
Because like that's what you do like for like hydrofluoric acid, hydrochloric acid, like it's just a binary acid rule.
Okay.
Yeah. Oh, I thought you were asking about the hydro, but yeah, just like, and like also you kind of like know like hydrochloric acid, you know what I mean? So like see it like that, like find like a common example. But you're right, that would have been like a little confusing. But if you know like that acid, like you know HCl, you can just compare it to that one. But that's definitely like a part of it. Like you add the ic at the end for those acids. Okay, and so like for this type of question, it's just you're working backwards, right? So I'm given chlorus. Us goes to what? Ite or ate? Ite, right? So I'm really dealing with chlorite, which would be ClO2, right? And whenever I see an acid, what does that mean? H, basically. So yeah, this is just where I'm giving you the word and you give me the formula, right? And so hydrofluoric acid would be HF, right? Whenever I see the word hydro, I know that I'm not dealing with any oxygens. I have the ic at the end, and fluoric means F, right? Okay, so it's pretty simple as that. So if it's a little confusing, definitely like make sure you look over that chart in your textbook. I think he did post like a picture of that chart in your PowerPoints, but I just like try to like, you know, finalize how you understand it because they're all like very interrelated. Let's just do molecular real quick, just so I know like for sure that we got like all the namings done, right? So we have BRF5. What would I name that? So it's kind of the same as ionic compounds, but what is different regarding like naming molecular compounds regarding ionic compounds? Like what's a little different between them? The number prefix. Good job, right? And whenever I'm dealing with one, do I add a mono or no? No, right? So that's really the only difference. So it'd be bromine. What? What would the prefix for 5 be? Good job. Pentafluoride. Okay, and then this one would be what? N4SE4. Tetra nitrogen and tetra what? Tetraselenium. Selenium. Sorry. Yeah. Se is selenium, but selenium you change the back to ide. That's the same thing that we do with ionic compounds, right? Like potassium chloride stuff. So it's kind of like the same thing. It's just like small differences, right? So whenever you're dealing with molecular compounds, you name out the prefix. Okay. And then CO2 basic, we know that as carbon dioxide. So usually like what I say is for each type, maybe like know like one for sure. So like carbon dioxide is a molecular compound, hydrochloric acid as like the binary acid, and then you can always like compare it to the other examples if you're confused on the test, for example. But yeah, it's as simple as that.
A really fast question.
Yes.
Number 24, you don't have to do it, but like grams to moles is just molar mass, and then moles to molecules is just all the larger number.
Yes, 1 mole equals 6.022 times 10 to the exact. Okay, so Ca what?
What's the words?
A carbon dioxide, sorry. Okay. So Shannon, what was the question that you wanted us to do, 33? Okay, so let's get to that question before anything. Okay. Oh yeah, this is definitely a good question. It is asking for the limiting reactant, the theoretical yield, and the percent yield. So it's basically like everything regarding chapter 4 in one question. Let's see. Okay, so let's first break it down, right? Let's talk about it conceptually. Limiting reactant, what does it mean? Is it the reactant that's used up first or used up last? Used up first, right? So it's always the one that determines how much we can actually make. Our theoretical yield always has to do with the amount of product we can make, right? While a limiting reactant is the reactant value. And percent yield, what is the formula for percent yield? Times 100, perfect. So good, yeah, we got it, okay. So are we finding the actual value or the theoretical value? We find the theoretical value, right? And the actual value is always given to us because the actual value has been conducted from an experiment. So in this question, let's read it. Lead ions can be precipitated from solution with KCl according to the reaction. So they give us an equation right here. And they say when 28.5 grams of KCl is added to a solution containing 25.7 grams of Pb2+, a PbCl2 precipitate is formed, solid, right here. The precipitate is filtered and dried and find to have a mass of 29.4 grams. Okay, what value is that, actual or theoretical? Actual, exactly. Actual given to us in the problem, unless you actually conducted the experiment yourself. Okay, so percent yield equals actual divided by theoretical times 100, right? So we already kind of know, like in order to answer this question, we can already kind of like fill in a little bit. 29.4 grams times 100, right? And we need to plug in T. Cool. And then it says determine the limiting reactant, the theoretical yield, and the percent yield, right? So they want us to find the theoretical yield of PbCl2. This information is important. Why? Why is that important? Why do they specify PbCl2 instead of K+? Because those both are products, right? What does that tell us to do? Like, how does that influence how we're going to answer this question?
Is that the product you would use when finding the limiting?
Exactly, right? Because you could do the other one and still find the limiting reactant, but you're also kind of wasting time when you want to plug it into the actual and theoretical. So that's why I kind of want you guys to understand it conceptually, why you want to find certain things, because like you said, you can do K+ to find the limiting reactant, but you're just wasting time. Okay, so let's find the limiting reactant. How do we find the limiting reactant? Can someone help me set it up? I have 28.5 grams of KCl. What do I do with that? Okay. Okay, so convert it to moles, right? So 1 mole of KCl. How many grams are in 1 mole of KCl? Does anyone know? 18. I'm pretty sure, because I think Cl is like 35. So let me see, like, I'm pretty sure I wrote this down, so let me, it's 74.55. Okay. So we have 1 mole of KCl. Okay. Now where do we go with this? I know we said we want to relate it to PbCl2, right? Mm-hmm. Thank you. 2 mole of KCl. Okay, so what do I get? .1911, right? Okay, so that's how much I yield when I have this much product of KCl, right? So now let's do the same thing, but let's do it with Pb2+, right? Just so we can see whatever value we get. Whichever one is the lower will be our limiting reactant. Okay, so 25.7 grams of Pb2+ times 1 mole of Pb2+, and the grams of 1 mole of Pb2+ is 207.2. Awesome. There's 1 mole of Pb2+ to 1 mole of PbCl, right? So it's 1 mole Pb2+. Just writing it out just so we understand it, but it's basically just times 1. Can someone calculate that for me and tell me what they get? It'd be like a 0 point something number. 0.124 mole of PbCl. Thank you so much. Okay, so now we have 0.1911, 0.124. What is my limiting reactant? Pb2+, exactly, limiting reactant. Limiting reactant is your lower amount, right? Okay, so now we have the limiting reactant. So we answered one of the questions, right? So I'm going to cross it out. Is my theoretical yield, do I have to calculate it, or is the answer given to me? Exactly. So your limiting reactant is your reactant value. Your theoretical yield will be the product value. So you can find both answers through one process, right? And we found them in one process because we focused on that one product. Okay, so this would be our theoretical yield. Theoretical yield would be 0.124 moles of PbCl2, right? Now, yes, you can put it in grams or you can leave it as moles, right? Like when you want to find your answer. If your answer is given in theoretical yield like as grams, then change it to grams. But if it's left as moles, you can leave it as moles, right? But now we have to find the percent yield for this reaction, right? So we already know the grams of the actual. Now we need to know the grams of the theoretical and then times it by 100. So it's basically what we have right here. But like you said, let's change it to grams so we can plug it in to find percent yield. So you have 1.24 moles of PbCl2 times 1 mole of PbCl2 equals how many grams of PbCl2? Let me see if I have that somewhere. Yeah, okay, so I have the value right here. It's 278.106. Is anyone confused regarding like formula mass, or is everyone good on that? Because I'm kind of just like straightforwardly giving it, but as long as you guys are good on that, then we don't have to like waste time on that. It's just the value molar mass of this plus 2 times the molar mass of Cl, okay? So can someone tell me what they get when they multiply 0.124 times 278.106? What do you get? Thank you. So you get 34.5, right? 34.5 grams. Okay, so this is another thing to make sure and check that you're on the right track. Usually, your theoretical yield is always the maximum amount that you can make, right? And whenever you conduct an experiment, you're prone to make mistakes in your experiment. Sometimes like you spill something or like you drop something. And in that case scenario, what I'm trying to say is like your actual must always be less than or equal to your theoretical. So basically we're in good terms right here because 29 is less than 34. But if 29 was larger than 34, then you know you kind of like did a step wrong, okay? So it's just small ways of checking yourself while you're doing the problem. So 29.4 divided by 34.5 times 100, what do you guys get? 85. Yeah, awesome. So 85. So 85% accurate was this experiment. Okay? Yes? Yeah, there is another question there's another question on that. Let me see if I can like find it, because I try to like make sure we get to it, but let me see how much time we have. Okay, so we're at 1:44. I am supposed to like kind of like bring like a conclusion like by 1:45, because I do have to pass some papers out to you guys, but let me see if I can find it while I pass the paper out. So what I'll do is, it's okay. What I'll do is I'll just like split it in half. Everyone just kind of take one, pass it down. Hey guys, can you guys take one, pass it down? Yeah. Thank you. Okay, so let's see. Basically she brought up a good point. She was saying whenever you're dealing with limiting reactant, you should be able to also find the excess reactant, right? So I have a question on that. Let me see if I can I put it in here, so I'm just going to try and find it really quick, and we can talk it through conceptually real quick. But what we're passing around is just like a sheet. I hope you guys can kind of just say what you thought about the review. If you've been attending SI sessions frequently, kind of what you think about it. Kind of be truthful with it, if you like it or if you don't like it. It's only for us to improve our program and to help you as much as we can. So yeah, so you guys can start working on that while I try to find this problem real quick. Okay. So yeah. Number 32 is an example where I kind of just straightforwardly asked for the excess reactant. Let me see if I can find it on my paper. So we are running out of time because I can't keep you guys here till past a certain amount of time. But I'll just quickly explain it to you, and I'll post my answers with everything written out, right? So usually what you do when you find the excess reactant is you first find which the limiting reactant is, right? So they gave us two reactants right here. They gave us zinc sulfide, and they gave us oxygen, right? So from here, you're going to first find out what the limiting reactant is. That affects your results, right? So in this case scenario, the limiting reactant was O2, okay? So 6.9 moles of O2 was the limiting reactant. So when you want to find your excess reactant, everything you relate it to the limiting reactant, because the limiting reactant affects the whole thing. It determines how much excess reactant you have, how much product you have, and so on and so forth, right? So first find LR, right? And then relate LR to ER, excess reactant. So what you do is you use this formula, right? Not this formula, but this equation right here to relate zinc S to O2, right? So it'd be there's 3 moles of O2 to every 2 moles of zinc S. Does that make sense? So relate it first, and then you find the moles value of that, and then whatever value you get from here, you subtract it from, one second. Yeah, you subtract it from what you had available, right? So can someone tell me what they get? 6.9 times 2 divided by 3, what do you guys get? 4.6, right? So this is how much you actually needed for this reaction. So exactly. So what you'll do is you have a total of 4.8 minus 4.6, so your excess will be 0.2 moles. Good job. So it's just kind of thinking a step further. But anytime they ask you to find anything, always related to the limiting reactant. Limiting reactant determines every part of this question. But that was the whole conceptual idea regarding chapter 4, right? Okay, guys, so hopefully you had time to answer through the survey sheets. Any last minute questions that you guys want to bring up? Any last minute questions you guys have, like regarding any topic? No? What number? Please bubble the number. Oh, don't worry about that. They'll bubble that in, like, because I don't even know that value. But yeah, so based on like what we just went through, some small things to look over: oxidation rules, right? Solubility rules. What else? Yeah, the oxidation state rules. Look over how to name ionic compounds, covalent compounds, the acids, the general rule of those. What else? The formula for percent yields, how to find your limiting reactant, excess reactant, delta E equals Q plus W, like the formulas for chapter 6 thermochemistry, like all those energy formulas that we worked through. But other than that, like chapter 1 and chapter 2, like as you guys can see, everything has been a buildup, right? Like finding that formula mass so then you can apply it in chapter 6 later on. So if you can do like 6, 4, and 3 solidly, then 1 and 2 should be like a breeze when you're reviewing it, okay? But yeah, good luck on your whole exam. I really hope like it's a good exam and it's phrased correctly so you guys do amazing and you guys excel. But yeah, good luck this semester and hope you have a great break. Yes, thank you. Yes, thank you.
Thank you.
Thank you.
Yeah.
Okay, thanks, girl. Thank you. 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 Sorry, no, sorry. Thank you. Thank you.